discussing in class. What we have right here is a General Electric jet engine. Now, this particular engine was used on a fighter jet. This engine has the same components, though, that we see in our steam-powered power plants as well. So what I want to discuss and show you today are the three major components of these engines. We have the compressor section, the combustor section, and then the turbine section. Now, here in the compressor section, we have 17 pairs of blades that compress the air that comes in the front of the engine to a pressure ratio of 13:1. And down here we can see some of the lines, not all the lines, but they're color-coded so that we can see the electrical lines in green, the oil lines are in yellow, the fuel lines are in red, and the air lines are in blue. Now we'll move on to the combustor section. We'll see what happens after the compressor. Now here we have the combustor section. So we have 10 cans that are arranged around the center line of the engine. This can's been removed so we can see a little bit of the interior here. The fuel is going to be injected annually, and we're going to burn that fuel with the air in this section. That's going to increase the temperature of the air, and then we're going to take that high temperature, high energy fluid, we're going to pass that to the turbine, the next section. All right, here we have the turbine section. So we take the high energy fluid, which is the combustion products and air, that's got a high temperature. We're going to expand through 3 stages of turbines. We can only see the third stage blades here. The other 2 have been cut away, so we can see the axis of the jet engine. Now, this axis is what we use to harness the energy that's coming from the turbine to power the compressor upstream of the turbine blades. So the remaining energy is used to develop thrust for the engine. So we take the energy left over that's not used for the compressor, we put that through the nozzle, and that provides the thrust for the engine. Now we can see this is a really complex engine, and we have 17 stages of compression, we have 3 stages of expansion. So we simplify this system quite a bit in our class. But the basics we do cover. But what we want to realize is you can see these blades are highly 3-dimensional. And of course, within the first week of class, we assumed 1-dimensional systems. So that simplification is fine for thermodynamics, but if we wanted to design jet engines, or if we wanted to design turbines that are used in power plants, we do need to bring that complexity, that multi-dimensional behavior back into our analysis. And that would require some additional skills, heat transfer, fluid mechanics, and some of the other courses that you may want to follow on and take. The other point that I want to draw to your attention is that this is a jet engine, so it's relatively small. In jet engine applications, we have to take into consideration the weight. That's a huge issue associated with air travel. Weight to thrust is a major metric that's used for evaluating engines. But when we have steam turbines, weight doesn't matter, they're stationary. So steam turbines and steam compressors, pumps of what we studied in class, will be much larger than these. So if we were looking at a comparison for this turbine stage to a turbine that's used in a power plant, we'd see that turbine's going to be probably 3 times as high.